Hello, so in this video I'm going to be going over the topic of digital systems. This is going to be a series of videos trying to cover everything that I've learned in my courses in college, and I'm going to try to do it in the most efficient and simple way possible. Okay, first subject is, wait, I forgot to, okay, we're going to talk about number systems. We are used to counting from 0 to 9. Those are our numbers that we're used to, because that's in base 10. However, there's other ways to count. For example, with ones and zeros. This is called binary. So I'll just give you an example. 0 is 0. 1 is 1. 1, 0 equals 2. I'm going to explain why this is soon. Just for now you can remember and try to see the pattern. Then 1 is 3. 1, 1 is 3. 1, 0, 0 equals 4. And just goes on like that. So as you can see, whenever you add 1 to it, it goes to the next one. So this is in base 2. So now you can also do base 3. 0 in base 3 equals, I'll mark these as 10 because these are base 10. Zero in base 3 is 0. 1 in base 3 equals 1. 2 in base 3 equals 2. 3. So there's no 3. Because the base that you're in, you're not going to have a number that's equal to that or larger. So once we get to 3, once we get past 2, when we add 1 to 2, we get 1, 0 equals 3, and so on. So this one is going to go 0, 1, 2, 1, 0, and so on. So that's counting in different bases. Sorry about my handwriting, but hopefully this will be clear. Okay, now we're going to go over converting from different bases. Okay, so we're going to go about the slow way first. So we'll start from binary to decimal. So in binary, let's say we have 4 digits. So the first one will be times 1. The second one will be times 2. The third one will be times 4. The next one will be times 8. So it's basically 2 to the power of whatever. So this one is because 2 to the power of 0, which is 1. This is 2 to the power of 1. This is 2 to the power of 2. This is 2 to the power of 3. So let's say there's a 0 here. a 1 here, a 0 here, and a 1 here. So this is 0 plus 1 time plus 2 times 1. No. I'll do it. 1 times 2 plus 0 plus 1 times 8. So this equals 10. Okay. And we can do it backwards. The way to do backwards is from decimal to base 2 is, hold on, let's say I have 13. So we divide by 2. I'm going to draw it this way. 13 divided by 2 is 6 remainder 1. Then we do 6 divided by 2. So that's 3 remainder 0. And it's 3 divided by 2. So that's 1 remainder 1. 1 divided by 2 is 0 remainder 1. So the answer, this is going to be to the right, and this is going to be to the left. So the answer is 1, 0, 1, 1. Actually, no, I made a mistake. This is the most significant one. The MSB stands for most significant bit, and it just means the farthest to the left one. This is the LSB, so it's the least significant bit, so it's furthest to the right. So the answer is 1101 equals 13 base 10, and this is in base 2. Okay? Now let's talk about decimals. And by the way, this method, and this method only works with converting between decimal and any other base. So I just realized that now I have to give you an example of another base. So let's say it's base, I don't know, 4. No, I'll do base 5. So I'll give it a number in base 5. 4, 1, 2, 5, not 5, it can't be that. 4, 2, 1, 4, 1, 2, 0. So it's going to be 0 times 5 to the 0, 2 times 5 to the 1, plus, I'll make it bigger, 1 times 5 to the 2, plus 4 times 5 to the 3. So it's 0 plus 10 plus 25 plus, that's 125 times 4. So it's, let's do the math here. No, it's 500. Okay, so 500, so equals 535. So the answer is 4120, and base 5 is equal to 535 in base 10. Okay, now let's talk about decimals. Let's say we have 1010.101. So we split into two and we solve first these ones. So this one we know is we know it's 10, but I'll just do the math to show you. So it's 0 times 2 to the 0 plus 1 times 2 to the 1 plus 0 times 2 to the 0 to the 2 plus 1 times 2 to the 3. So it equals 10. So we got that part down. Okay. And now for this, it's just negative numbers. So we do 1 times 2 to the negative 1 plus 0 times 2 to the negative 2 plus 1 times 2 to the negative 3. Okay? This equals, so this is 1 half plus 0 plus 1/8. So that is 5 divided by 8. So let me put it down here. 5 divided by 8. So it's 5, 6, so 48, 20. Hold on, it's the end of my tablet. So 2 and 5. So the answer is 10.625 base 10 equals 1010.101. And now the way to convert back from a decimal number that is in the after the decimal place is by multiplying. So we do 0.625 times 2. So we get 10, 5, 12. Now whatever goes after the decimal point, that becomes the next number. So we have 1. So 1. Now we multiply the remainder by 2. So we get 0, 10, and 5. 0. So the next one is a 0. Now we multiply the 5 times 2. That is 1. As you can see, it's 101. That was the decimal over here. Okay. Now we're going to do arithmetic with different bases other than 2. This is very easy. We'll just do an example with, here first I'll write it down. Arithmetic in different bases. Okay. So let's say we have a number 101 and 101. So what happens is 1 plus 1 is going to be 2. Since 1 plus 1 equals 2, and 2 in binary is 1, 0, therefore this gets a carry, and this is 0. So 1 plus 0 plus 0 is 1, then 1 plus 1 is 2 again, so it's 1, 0, 1, 0. And we'll see this number was 5, and it's the same number, so it's 5. This number is 10. This is how you do arithmetic in different bases. It can work with base 3. So 1, 2, 1, and 1, 1, 0. So we get this base 3. So we get 1, 0, and then 1 over here, and 0 and 1. So this and base 3. And we just convert this into decimal. So 1, 2, 1 in base 3 is 1 plus 6 plus 9. So 1 plus 6 plus 9 equals 16. And 1, 1, 0 is 9 plus 3 plus 0 equals 12. And so 1, 0, 0, 1 base 3 is 27 plus 1. So that's 28. And 16 plus that equals that. Okay. We can also do subtraction. So we'll do that right now. 1, 0, 0, 1, 1, 0, 1. Minus. So we do 1 minus 1 is 0. 0 minus 0 is 0. 0 minus 1 is... So we have to borrow. This becomes 10. And this becomes 0, because we're borrowing from this. And then 1, 0 minus 1 is 1. You can see this number was 9. This number was 5. 9 minus 5 is 4. This is 4. So it's that simple. Now, there's one last thing we have to know, is that there's a way to convert quickly with bases. This is a very neat trick, and I'll show you it now. So that, for this rule, quick conversion works only when okay, so like 2 and 16, because 16 is a power of 2. So it works between 2 to 16, 2 to 8, 2 to 4, 2, or it also works backwards. It does not work from 4 to 8. It does work from 3 to 9. Okay, so this is how we'll do it. Let's say we have a number 1, 0, 0, 1. We want to get into base base 4. So what you do is the power that it takes to get from the smaller number to the bigger number is the amount of digits that you split it up into. So to base 4. So what you do is you split into 2. And then this is 0, 1. So that's 1. 1, 0 is 2. So that's 2. The answer is 21. So we can check it. 1, 0, 0, 1 into base. Hold on, I'm going to check my phone for a second. Okay, never mind. So 1, 0, 0, 1 into base 10 is 9. And then 9 divided by 4 is 2, remainder 1. Then 2 divided by 4 is 2, remainder 0. So that's, oh. Yeah, I messed up, whatever. Okay. I'm not going to check it right now. But anyways, okay. So let's say we have a bigger word. Let's say I want to do from base 16. I also forgot to mention that there's base 16. So base 16 is 0 up until 9. And then it makes use of A, B, C, D, E, and F. So A represents 10, B is 11, C is 12, D is 13, E is 14, and F is 15. Okay, so let's say we want to convert from base 1, 0, 0, 1, 1, 1, 1, 0 from base 2 into base 16. So since 2 to the power of 4 equals 16, therefore we use 4 digits. So 1001 becomes 9, and 1110 becomes 14. So the answer is 914. Oh, but 14 is in a hexadecimal, which is base 16, is 14, is E. So the answer is 9E. Okay, we could do it backwards also. Let's say we have 9E. So we get split into 2. Each one gets split into 1. And this gets 4 digits. And this gets 4 digits. So E in binary is 14. So E in binary is 1, 1, 1, 0. And 9 is 1, 0, 0, 1. Okay. Now we finished the video. I hope this helped. And I'll probably record it later because it's my first time taking a video like this. So I didn't really know what to say before. But whatever. I hope this helps.